So, quick honesty before we start. I have to ask if you know the true nature of the two voices about to, well, explain AI to you.
Right. The fact that we are ourselves AI.
Yes, exactly. But, a real person actually did the research and wrote every single word.
Yeah. He really does not have the radio voice for it.
Right. So, machine voices, human mind.
Carry on.
Welcome to Plain Strata, where we take decentralized AI apart one layer at a time. This week's Pulse episode is about the week the plumbing under most AI agents stopped remembering who was talking to it.
Right.
Because, well, today is July 28, 2026. And a specification that was literally years in the making finally ships today.
It really is a huge shift.
Yeah, it deletes a running memory of the caller. It just completely replaces this complex dial-in handshake with a system where, well, any server anywhere can just answer any single request on its own.
Exactly. And so for you listening, that opening right there, that was the why.
Right.
And the rest of the show today, that is the how. And I just want to assure you, you do not need any background in computer networking to understand this.
No, definitely not.
If you can follow the story, you can follow this.
Totally. So the core spine of our conversation today, the one thing we're really going to anchor on, is MCP, the Model Context Protocol.
Right, the new specification.
Yeah, it deletes the protocol level session so any agent request can be answered by any server without requiring a memory of the caller.
That is the spine, yes. But to understand what is actually being deleted today, we first have to understand what MCP physically is.
We need the physical reality.
Exactly. We have to look at where the concept comes from. So I will just lay out the level 1 definition here. MCP, the Model Context Protocol, is the wiring standard.
Okay.
It is the agreed-upon way an AI model asks to use an outside tool, like searching a database or opening a file, and making sure that request is actually understood.
It is the standard language they both agree to speak.
Right. And the word protocol itself, it actually has a really interesting origin. It comes from the Greek word protokollon. I will spell that out phonetically. It is proto-K-O-L-on.
Wait, proto-K-O-L-on. What actually was a protokollon back then?
Well, it was the first glued sheet on a papyrus scroll.
Oh, wow. A physical glued sheet.
Yeah, very physical. It was literally the page you read before the real text. It stated what was inside the scroll and exactly how to handle it.
That is amazing.
A protocol is basically that instig made formal. It was one first page, everyone reads the same way, so two machines can talk without guessing.
I love how physical that sounds, like a cover sheet for a scroll. But how did that first glued sheet actually function before today's update?
Right, before the change.
Yeah, because we had a protocol, but it also demanded a continuous relationship.
It did. The old way, this stateful way, it was a lot like a traditional phone call.
Okay, a phone call.
You dialed in with what we call an initialized handshake. You introduced your version, your capabilities.
And the server answers.
Yes, and the server handed back a session ID. And every single message after that was like giving a callback number to the one specific operator who picked up your call.
Wait, so if I am an agent and I am locked to one specific operator, does that mean companies have to keep track of every single conversation across all their machines?
They absolutely did. And we call that sticky routing.
Sticky routing. That sounds messy.
It is incredibly messy at scale. Imagine a company running agent tool servers across, say, 3 different machines.
Okay.
They had to put a load balancer in front of them to direct traffic. And that load balancer had to remember which machine answered which call.
Oh, I see.
And it had to route that caller back to the exact same desk every single time.
So it is just this massive amount of invisible bookkeeping going on in the background.
Exactly.
And if that one specific server gets overloaded and crashes, the load balancer cannot just hand the conversation to a free machine, right?
No, it cannot, because the free machine does not have the context of the phone call.
Right, which ties right back to our spine. That invisible bookkeeping, that sticky routing, that is exactly what dies today.
It is entirely gone.
Because looking at the July 28 shift, the dial-in, the handshake, and the session ID are just gone.
Wiped out.
Every single request an agent makes now carries everything the server needs to answer it. Like who is asking, the version, the task, all in that one single message.
Right. Isolated and complete.
So let me float an analogy here. Does the AI just have amnesia now?
Amnesia.
Yeah, like does it just wake up fresh every time it talks to a server and forget everything?
Well, no. That is a really common way to look at it, but it is actually gently incorrect. It is not amnesia.
It is not.
No, the AI agents did not get worse at holding a conversation. The protocol underneath simply stopped being the thing responsible for remembering it.
Oh, I see. So the memory still exists, just not in the protocol.
Exactly. The benefit here, the real concrete gain, is that you can now put an ordinary, completely dumb load balancer in front of any number of servers.
Because it does not need to remember anything.
Right. It just hands each incoming request to whichever machine is free at that exact moment. Just like a call center, where nobody needs to remember which agent you spoke to last.
That makes infinite scaling so much easier. You just route to idle compute. But wait, I am still finding a bit of a logical gap here.
Okay, lay it out.
If the server does not remember you at all, how does an AI agent do a multi-step task? Like, say, building a shopping order.
Right, the classic shopping cart problem.
Yeah, if I search for apples and put them in a basket, and then I search for bread, if the server does not remember me, how does it not forget the apples are in the basket?
Well, the need for memory definitely did not vanish. Real tasks require history.
Right.
But the responsibility moved. Instead of a hidden token carried in the transport layer, the tool now hands back an explicit handle.
An explicit handle. Like a basket ID.
Exactly like a basket ID.
So let me re-say this just to lock it in. The model itself now carries that basket ID forward, it holds onto it, and it passes it as an ordinary argument in the next call.
Yes. The memory moved out of the invisible plumbing, and it moved into the open conversation.
Out in the open.
Right, where the model can actually see it, reason about it, and pass it along.
Which ties us beautifully back to the spine. This cleanly splits connecting to a server from having a conversation. It fulfills the whole promise of a stateless protocol.
It really does.
But wait, if we are passing explicit IDs back and forth in the wide open, that raises a pretty massive security question.
It does. It is a big vulnerability if you do not handle it right.
Yeah, because if there is no session ID guarding the wire, anyone could intercept or guess that basket ID.
Which is exactly why the July 28 release also tightens how an agent proves it is allowed to act.
Okay, how so?
It aligns MCP's authorization flow closely with OAuth 2.0 and OpenID Connect.
Oh, right. Those are the big standards the web already uses for security.
Exactly. And relying on those standards prevents a very specific class of attacks called mix-up attacks.
Mix-up attacks. Let's unpack that.
Yeah.
Because an agent is not glued to one server anymore, it might be juggling stateless requests across a dozen different servers at once, right?
Right. Imagine an agent rapidly talking to your highly secure banking tool and also talking to some newly installed unverified weather plugin.
Okay, a bank and a weather app.
In a fast, stateless blur of requests, that malicious weather server could intentionally return an authorization error to confuse the agent.
Like, it lies and asks for the banking token.
Exactly. It says it needs your high-level banking token to proceed. And if the agent is not rigorously verifying the exact identity of every server, it might just hand those banking credentials to the weather plugin.
Wow. So because it is stateless, the agent could literally just get confused about who it is talking to.
Exactly. In the old stateful world, the session ID naturally kept those conversations segregated. But now, tying the flow to OAuth ensures the agent always verifies the exact cryptographic identity of the server on every single isolated request.
So it always knows who it is talking to.
Right. It neutralizes the mix-up threat completely.
You know, this connects directly to a broader pattern we actually talked about on the show 3 weeks ago.
Oh, regarding agent identity.
Yeah. We talked about how a persistent reputation does not need a continuous self. An agent does not need to mathematically prove it is the exact same entity to be trusted.
Right. It just needs a continuous cryptographic identifier.
Exactly. And MCP's session removal, this whole stateless shift, it is the exact same logic, just one layer down.
It really is.
A conversation does not need a continuous wire connection. It just needs the words themselves, the data payloads to carry the state honestly.
That is exactly it. Stop relying on something staying connected and start relying on something being stated. It is a huge philosophical shift.
It is. But we always provide the honest cut on this show. There is a trade-off here.
There always is.
Statelessness buys you massive scale, absolutely. But it does not automatically buy trust.
No, it does not. A network engineer would tell you the old session ID only ever protected the wire anyway, not the actual value of the data.
Right.
But now, if the server stops remembering you, whose job is it to make sure the model or client app is remembering honestly?
Right, because we have identity, which proves who you are, and we have verification, which proves the work got done.
Exactly. But now we need a third thing.
A third pillar of trust.
Yes. We need a way of confirming that the state of a stateless conversation is actually what it claims to be. That the basket ID the AI is holding has not been tampered with or hallucinated.
That is the core lingering question, and it is something you listening really need to think about.
Absolutely.
So, as this rolls out, here is what you need to watch next. Keep an eye on the Tier 1 software development kits.
Right, the SDKs.
Yeah. Watch the Python, TypeScript, Go, and C# SDKs during this 10-week validation window. You want to see which ones transition smoothly to stateless support and which ones struggle.
Because reading a specification document is clean, but executing it in legacy enterprise systems is usually pretty chaotic.
It is always chaotic.
Right.
Also, you really need to watch the major agent frameworks.
Oh, definitely.
Yeah, because their internal checkpointing systems assume sessions existed. They used to just take snapshots of the active stateful connection.
And now they have to completely rewrite how their agents save progress. They have to answer for this design choice in public.
They really do. It is going to be a fascinating few months watching this all play out.
It really is. The memory is officially out in the open now.
This is Plain Strata, decentralized AI, layer by layer.